So we're going to go ahead and take this stuff to the next level and see more real-world situations, because in the real world, things don't really occur in one dimension. So an example of something that you can apply this to is pool, billiards, right? So when you hit a billiard ball with your stick, you send it off with some initial velocity and some angle, depending on how hard you hit it and in what direction. That ball is then going to collide with something else. You hit the white ball, and it hits the ones with the stripes and the ones that are solids, and you want the stripes and solids to go in the pockets, which requires you to hit them at certain velocities and angles so that these other balls go off with different velocities and angles into the pockets. So the people who are really good at pool pros, can do these calculations in their head and have spent years practicing to do them by feel. So we're going to see what kind of calculations you need to do in order to get these types of collisions to happen. So, in this problem, a billiard ball is traveling to the right at 1.5 meters per second. So, a billiard ball weighs 0.25 kilograms, and it's traveling to the right towards another billiard ball at 1.5 meters per second. So we hit it with a stick, and it's striking an identical stationary ball. So identical means it has the same mass and zero velocity because it's stationary. So the only thing that's different is it's a different color or it has some stripes versus not. What's then going to happen if one ball is traveling at 45 degrees with respect to the horizontal and at a speed of 1 meters per second, what is the speed and direction of the other ball? So these guys are going to collide perfectly elastically in a glancing collision, so that one ball is going to go off in a direction this way, so up and to the right, at an angle with the horizontal of 45 degrees, and a velocity of 1 meter per second. So, what will happen to the other ball is that it will go down and to the right with some unknown angle and some unknown velocity. So, if you hit a pool ball and you want it to go into a corner pocket, you have to hit it with a perfectly elastic glancing collision, and you can calculate where it's going to go. So, since we're going back to 2 dimensions, it's important to define our coordinate system. So, right is going to be positive x, left is going to be negative x, up is going to be positive y, and down is going to be negative y. So then we take this to our after collision, positive x, positive y, negative x, negative y. So, we're now going to we're going to call this ball 1, or let's call it A, and ball B. So A, B. So, ball A, it has a mass of 0.25 kilograms. It has an initial velocity in the x direction of 1.5 meters per second. In the y direction, it has 0 meters per second because it's only going to the right. Which means that our x component is of our momentum. So PA initial x. I know it's a lot of subscripts, but it's so we don't lose track of things. So the momentum of A initially in the x direction is 0.25 times 1.5, which is 6 kilograms meters per second. In the y direction, PA initial y, since we have a 0 velocity in the y, this guy is just 0. So, we have PAIX is 6 kilograms meters per second, and PAIY is 0. So now, we're going to go to ball B. it has a mass of 0.25 kilograms. In the x direction, it has a velocity of 0. And in the y direction, because it is stationary. So, in the x direction, we have PBIX equals 0. And in the y direction, PBIY equals 0. So our initial momentum has to be broken down in the x and y components. So PIX is equal to PAIX plus PBIX, which is 6 kilograms meters per second plus 0. 6 kilograms meters per second. PIX. PIY is equal to PAIY plus PBIY, which is equal to 0, because both of those guys are 0. So we now have our initial momentum in the x and y direction. So now we have to go to our final momentums and look at those in both of those directions. So we're going to start with ball A, and this is where things are going to get a little bit more complicated. So, ball A still has the same mass, 0.25 kilograms. It has a velocity of 1 meter per second and a theta of 45 degrees. So that means that it is a right triangle with hypotenuse 1 and angle 45. So if we want to find VAY and VAX, we have to use SOHCAHTOA. So, opposite, adjacent, hypotenuse. So opposite over hypotenuse is sine of 45 is equal to VAY over 1. So sine of 45 degrees is VAY of 0.85, 1 meters per second. So let's box that because it's a answer. And then cosine of 45 equals VAX over 1. So cosine of 45 degrees, VAX is 0.525 meters per second. So, let's go ahead and erase these guys and get x 0.525, y 0.851. So, put it all together. X equals 0.525, y equals 0.851. Which means that let's make sure PA final x is equal to 0.25 times VAX, which is 0.525. 0.525 times 0.25 is 0.13125. And the units on this are kilograms meters per second. PA final y is equal to 0.25 times VAY, 0.851, which is 0.21275 kilograms meters per second. Cool. So now we need to go to ball B, which has a bunch of unknowns. Ball B also has a triangular shape. It has theta, and it has V. So VY and Vx, which are all unknowns. So, we need to break our V down into x and y components and then put it back together at the end of the problem. So, Vx is equal to V cosine theta, and Vy is equal to V sine theta. V and theta are both unknowns, so we're allowing it to be positive or negative. In our problem, we drew Vx to be positive and Vy to be negative. So we should be looking for those signs at the end to make sure we did the problem right, or we have to think about it. So, P B final x is equal to 0.25 V cosine of theta. And PB final y is equal to 0.25 V sine of theta. So, now we have to go and do P final x is equal to PA final x plus PB final x. PA final x was 0.1312, so 0.13125 plus PB final x, 0.25b cosine of theta. I know it's a lot, that's why we're going as slow as we possibly can. PFY is equal to PA final y plus momentum B final y. Momentum A final y is 0.21275. 0.21275 plus PB final y, 0.25B sine theta. So, in these two equations, we have our unknowns, V and theta. So 2 equations and 2 unknowns is all we need to solve something algebraically. So we now have to go ahead, let's zoom out a little bit. Oops. We know that PIx equals PFX and PIY equals PFY. So, PIx is 6, and that equals 0.13125 plus 0.25 V cosine theta. And then PIY is 0, right? And PFY is 0.21275 plus 0.25 V sine theta. So now we have our 2 equations and our 2 unknowns. So, since the PIY equals PFY equation is easier, let's go ahead and solve that first. So, we're going to subtract 0.21275 from both sides. Those cancel. Negative 0.21275 is equal to 0.25 V sine theta. We're now going to divide by 0.25 sine of theta to get B by itself. That cancels, that cancels, that cancels, and that cancels. So, if we do negative 0.21275 divided by 0.25, we get negative 0.851 over sine of theta is equal to V. So we've now isolated our velocity. So we take this velocity and we're going to plug it in right here. 6 equals 0.13125 plus 0.25 times v minus 0.851 over sine of theta, cosine of theta. And it's starting to get really algebraically gross, which is why we're going to keep going slow and keep using our signs. So, what I want to do is I want to move this guy over, 0.13125 from both sides. So 6 minus 0.13125 is 5.86875 equals. So let's do this multiplication. This guy times this guy. Next. 0.851 times 0.25 is negative, because there's a negative sign right here, 0.21275. Then we have a cosine over a sine, which is a tan. Is it a tangent or a... It is a cotangent. So this is cotangent of theta. So, I know it's gross, but it's just another button in your calculator. Don't freak out. So now we're going to divide both sides by negative 0.21275. Negative 0.21275. 5.86875 divided by negative 0.21275. Negative 27. Okay, I'm tired of writing these numbers, as I'm sure everybody else is, so let's just round to 6. So, just like you would do an arctangent, you can do an arccotangent, which I know is gross. So, cotangent to the minus 1. So this is going to be cotangent to the minus 1 of negative 27.6 is theta. Which is negative 2.075 degrees. All right. Does that make sense with what we expected? If we go all the way back up to our picture, we get theta 2.075 degrees. Which seems to make sense because it's negative, it means it's going down. All right. So now we have to go back to our velocity all the way down here. Oops. Undo. And plug in our theta. So V is equal to negative 0.851 over sine negative 0.75. 0.851 divided by that is 23.5 meters per second. So, if we go back to our problem, that means we get this is 23.5 meters per second. So our direction comes from our theta being negative, which makes sense because all velocity, hypotenuse part of velocity should be positive.